Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. So if the quality of video as well as audio is perfect, just write perfect over the live chat and then we are ready to go ahead. Anyways, we have spent around 20 number of days basis on live. There I discussed about all of the important as well as the basic part of the engineering mathematics. There I discussed about the different kinds of the important functions like logarithmic functions, parabolic functions, circular functions, elliptical functions, hyperbola functions, and even we discussed about the trigonometric functions. And in past 5 to 6 lectures we were discussing about the continuity, differentiability as well as limit. So from today onwards, we would be jumping into the next topic within the engineering mathematics, and that topic had been the calculus. Within the calculus, there are several kinds of the topics are involved, like differential calculus, like vector calculus, like integral calculus, like differential part of the applications. There are several kinds of the applications are being attached along with the calculus. Anyways, keeping aside each and everything, from today onwards, I would be just focusing over the one kind of the calculus, and that had been integral calculus. Many of the students had the request in yesterday's class, sir, why don't we start the probability? But I am not starting the probability just because of one thing. Because once you'll go into the deeper part of probability, where we would be discussing about the probability distribution, probability density, random variable, random process, there the integration has been a very crucial role. So until and unless you are not able to feel the concept of the integration, probably you would not be able to involve the things into the greater way. So that is why let me brush up the concept of the integral calculus, and once we are done with the integral calculus, I may plan straight away probability. So we are going to start integral calculus in today's part or in today's lecture. So each one of us should be writing the heading behind the today's video had been the integral calculus. Anyways, as far as the integral calculus is concerned, it had been a very wide concept. There I may be discussing about the definite integral, indefinite integral, single integral, double integral, triple integral, line integral. Even line can be bifurcated as vector line integral, closed line integral. Similarly, we can bifurcate this as a scalar line integral. Surface integral could have been bifurcated into two parts: vector surface integral, scalar surface integral, similarly the volume integral. So what I am saying, as far as the integral calculus is concerned, it is an intense topic. And each and individual topics are very important as far as the GATE syllabus is being concerned. So you cannot leave even any sort of or any type of integral. So yes, we are going to spend good amount of time over this topic. At very beginning, I am going to start with the very basic most type of the integral, and that used to be the definite integral. May I know what does it mean by the definite integral? The name itself is quite self-explanatory. You are going to integrate, you are going to consolidate, you are going to club the area under the curve between the definite limits. That means the integration sign would be there, but that sign would be bounded by its definite real values. So let me start with the definite integral. So each one of us should be writing the heading behind the today's agenda would be definite kind of integral. The name itself is self-explanatory. That means we have been using a reason where the definite area would be considered. Anyways, how the structure of the definite integral would look like, that we had to focus first. You would be having a sign of integration. You would be having a fixed real value of the lower limit as well as the upper limit. Within that, the integration would take place. Then you would be having function of x over dx, and the result is used to be written as the integrand of this given definite integral. I may write this as capital I. Yes, could you understand what I am saying? So in future, whenever you come across this situation where you have been assessing the area under a certain curve, The area had been bounded with what are the curves we are going to discuss over here. Area under a certain fixed curve, by default you have been dealing with the definite kind of the integral. Definite kind of the integral. So let me focus over the each and individual parts of this formation into the great detail. This sign is called the integral sign. So in future, whenever we come across this sign, we must have the clear-cut idea that we have been dealing with an integral sign. Similarly, towards the lower side of the integral, we used to have a real number. That real number denotes the lower limit of the integral. It's called lower limit. Lower limit. Similarly, towards the upper side of the integral, you would be having another real number, and that's called the upper limit of the definite integral. Upper limit. And at the same time, the dx indicates the integration has been taken place in reference with the x-axis. In future, even you can take the reference of y, you can take the reference of z. Even in polar coordinate system, you can take the reference of r and theta. Even in spherical coordinate system, you can take the reference of r, theta and phi. So what this d of x indicates, the differential part has been taken along with the x-axis, or the integration or the summation has been taken place with respect to the x alone. So what I am saying, let me take the understanding of this. That means the differential part has been taken along the x-axis. Integration has been made over the x-axis. Over the x-axis. Till this point, each and everything must be clear to all of us. And whenever we deal with the definite kind of the integral, the result would always be a real number. A real number. If the given integration is convergent in nature, real number. It could be positive, it could be negative, it could be rational, it could be irrational. But one thing I had been quite sure, once you'll solve this problem, the answer would not come in a form of function, it would be a pure real number. Could be negative, could be positive, it could be pi, pi is an irrational number, could be e, it is an irrational number, could be -2, which is a rational number. So one thing must be clear to all of us. Till this point, each and everything must be clear to all of us. Agreed? Now the next thing comes in mind, sir, that is fine, that we could understand this sign indicates for the sign of the integration, this indicates the limits of the integration, this indicates the domain at which the integration has to be done, this indicates the function for which the integration has to be made. Each and everything is very correct, sir, but why we are performing this operation? What is the need of it? And what it actually calculates? What it actually calculates? It calculates the area under the curve. It calculates the area under the curve. What I say? It calculates the area under the curve. Now, one thing comes in mind, sir. If you had to calculate the area under the curve, so certain boundation must be there. Like if we'll talk about the sine of x, obviously we take the integration of sine of x also. The sine of x is an infinite signal. It would not get terminate anywhere. So may I know when we would calculate the integration of sine of x with a certain fixed limit, which particular area is getting calculated? Now that's the point which I would be focusing more. So keep in mind, if we would be calculating the result out of this, it calculates the area under the curve which has been occupied or bounded by the four different restrictions. What are they? X is equals to a, that had been the lower limit. X is equals to of b, that had been the upper limit. Function f of x itself and x axis, or I can say y is equals to 0 axis. Choice is yours in which way you want to write this. In which way you want to write this. Agreed? Till this point, each and everything must be clear to all of us. And one more important thing, when we deal with the definite integral, the area is used to be signed in nature. That means while the assessment of the area, the certain lobe can be assessed as positive and certain lobe can be assessed as negative. What does that mean of it? It's not a pure area, because a pure area would always be positive in nature. But as far as the definite integral is concerned, certain of the lobe which has been made upside of the x-axis can be taken as positive. Certain lobe which has been made towards downside of the x-axis can be taken as negative. So one thing could have been sure to all of us, whenever we would be dealing with the definite integral, you would be having certain this sort of sign. In future, rather having f of x, you can have g of x, h of x, and even the integration can be made over the different variables, like you can have g of y over dy, g of h over dh, so on and so forth. So till this point, each and everything must be clear to all of us. So let me do one thing, let me take a graphical understanding of this complete concept. Deliberately I have taken a f of x which has been drawn over the xy plane, where the x-axis has been the axis over the horizontal, and similarly y-axis has been the axis towards the vertical. So what is happening over here? Let me draw a xy plane. Let me draw a xy plane. Here goes the x-axis. Here goes the x-axis. Here goes the y-axis. Here goes the x-axis. Here goes the y-axis. Now what is happening over here? Deliberately I have chosen a random f of x. Let's take the random f of x, looks something like this. It has been drawn something like this. Yes. And now that f of x has to get integrated, taking the reference of lower limit as a, upper limit as b. May I know x is equals to of constant, which type of straight line it used to be? It used to be a vertical straight line. Why? See, the displacement from y defines the value of x. And if you have fed the x is equals to of 1, what does it mean of it? That means you can be at any place, but the displacement from the y-axis has to be equals to of 1. So obviously, it has to be a perpendicular straight line vertically displaced 1 unit far from the y-axis towards right hand side. Could you understand what I am saying? So more or less x is equals to a as well as x is equals to b is gonna be a vertical straight line in parallel with the y-axis. Now it depends, would it be towards left hand side, would it be towards right hand side, depending on the polarity of a. Anyways, keeping aside each and everything, what I would be doing over here, I would just be focusing over its lower limit. Let's take the lower limit x of a had been towards left hand side. Let's take it had been x is equals to a, and similarly x is equals to b had been towards right hand side, has been towards right hand side. Let's take it goes somewhere here. It becomes at a right hand side. Could you understand what I'm saying? So as far as the definition of the definite integral is being concerned, it evaluates the signed area under the curve which has been entitled or encapsulated by x is equals to a, x is equals to b, f of x itself, and x-axis. So which area you are going to assess? Definitely you are going to assess this area, because towards left hand side it has been bounded by x is equals to a, towards right hand side it has been bounded by x is equals to b, towards upside it has been bounded by f of x, towards downside it has been bounded by x, towards the downside it has been bounded by f of x, and so similarly towards upside it has been bounded by x-axis. So till this point, each and everything must be clear to all of us. So may I know which area we had to assess over here? So obviously we have been focusing over this area. Which area? This area. We have been focusing over this area. This as well as this area. This area. So may I know, as far as the area is being concerned, which area would be taken as positive and which area would be taken as negative? Because as far as the definite integral is being concerned, the polarity or the area which has been made towards the upside of the x-axis and towards the downside of the x-axis used to be taken as positive as well as negative. Positive as well as negative. See what is happening over here. As the lower limit was towards left hand side and the upper limit was towards the right hand side, you yourself would be able to see graphically I have placed x is equals to a towards left hand side in compare with the x of b. What does that mean of it? That means while doing the analysis or integration, you have been moving from left to right. Left to right. Yes. Because your left hand limit was lesser than the value of right hand limit, or lower limit was lesser than the value of upper limit. Whenever you move from left to right, keep in mind all of the lobes which are made towards the downside, taking the reference of x-axis, they would be assessed as negative area. What does that mean of it? You would get the worth of this area. Obviously the worth of this area would be positive in nature, because the area used to be positive, but by default or categorically I would be marking this sign as minus because that lobe has been framed towards downside, Similarly, in the same fashion, if I would be discussing about this lobe, and as this lobe has been made towards upside, taking the reference of x-axis, definitely it would be treated as the positive area. So what I would do, I would calculate this area. Let's take this area had been mod of a of 2. Should I be writing this as plus or minus? Obviously, this has to be put it as plus. That has to be put it as plus. And when this situation occurs only and only if the lower limit is being kept towards the left hand side, or lower limit or the value of lower limit is being lesser than the value of upper limit. Could you understand what I am saying? Now let me ask one thing from each one of you. Let's take, I have displaced or I have swapped the locations of A and B. Let's take, it had been a location of A, it had been a location of B. That means the lower limit had a higher value in compare with the upper limit. May I know what's the change you would be experiencing while taking its definite integral? As far as the magnitude of this area is being concerned, it would remain mod of 2. As far as the magnitude of this area is being concerned, it would remain mod of A1. But as far as the polarity of their signs are concerned, as you have been moving from right to left, keep in mind all of the lobes which have been fabricated towards upside of the x-axis would be treated as minus, and which are the lobes which has been made towards the downside of the x-axis would be treated as positive. Could you understand what I am saying? Each one of you. Could you understand exactly what I am saying? So this notation, so this sign has been taken precisely when we have been moving from left hand side to the right hand side, left hand side to the right hand side. So till this point, probably each and individual concepts must be clearly known to all of us. Yes. So in the same sequence, let me go ahead. Let me take few number of numerical problems, rather going it to its graphical understanding. First, I'll put a mathematical equation or mathematical integral form, and from there you just have to tell the result, would it be positive in nature or would it be negative in nature. Let me take the first question. The question had been, the integration has been taken place from 0 to pi of a sinusoidal function sin of x dx. I don't want the exact answer, which you can do it easily by taking its antiderivative and by keeping x is equals to pi and 0. That is not has to be done. I just wanted to know whether its result would it be positive or would it be negative. I want the input from each one of you. The result, would it be positive or would it be negative? Nobody should solve this problem mathematically to get the exact answer. What I am saying, just try to figure it out how graphically sin of x would look like, and would it have the result as positive or would it have the result as negative. I want the input from each one of you. Tell me. I want the response at least from 2 or 3 number of people. The answer, would it be positive or would it be negative? Positive. The Sinjay Chakravarti says the result would be positive. Anyone else? Yes, the result would be positive. If you go ahead with a little bit graphical basis, you yourself would be able to understand how the sin of x looks like. It used to be a pure oscillatory signal with the constant magnitude and frequency. Let's take this axis has been dedicated over x, and this has been dedicated towards y, and this has been your function sin of x. You wanted to have the definite integral in between 0 to pi. May I know where the x is equals to 0 radian and pi radian would fall? Obviously in between 0 to pi. Yes. And one thing had been quite sure. What it is, as you have been moving from 0 to pi or lower limit to upper limit, your movement had been towards right hand side or towards left hand side. Obviously it had towards right hand side. So all of the lobes which would be framed above the x-axis would be treated as positive, and all of the frames or all of the areas which would be made towards the downside of the x-axis would be treated as negative. So may I know what has happened over here? I went from 0 to pi, that means the limit has been bounded from x is equals to 0 to x is equals to pi. That means I have nothing to do with the rest of the sun. rest of the signal. So if you would be focusing over this part of the signal alone, let me focus over this. One thing had been quite sure, what it had been, the curve has been made all together towards upside of the x-axis. That's the first thing. That's the first thing. And the movement has been from left to right. So once you'll calculate its area under the curve, definitely the result would be plus mod of this area, mod of this area. That would be the result. And if you calculate the integration of sine of x over 0 to pi, the result would be precisely positive. Result would be precisely positive. So here it becomes 0 to pi sine of x dx, sine of x dx. At very beginning, what we do? Obviously, we would take the antiderivative of sine of x. The antiderivative of sine of x would become minus of cos of x. Why? Because the differentiation of minus of cos x becomes sine of x, and the antiderivative as well as differentiation are the reversal process. And now I would take its limit. The limit is moving from 0 to pi. 0 to pi. End of the day, what we are going to do over here, the minus, the cos of pi used to be minus of 1, minus, now the x would be fed as 0, it would become cos of 0, which is again minus 1. So minus 1 and minus 1, they would get virtually added with a negative sign, it would become minus 2. End of the day, it is getting multiplied with a minus sign. The result had been plus of 2. And you yourself could have understood it very well. Yes, sir, the answer would be positive. Answer would be positive. Now, I would like to ask the next question. In the same way, let me frame another question. Rather taking the integration of sine of x from 0 to pi, I have stretched the value of upper limit a bit. Rather going till pi, I have been going till 3 pi by 2. Tell me, would it be positive? The answer, would it be positive? That's the first thing. And what would be the expected answer? What would be the expected answer? There are two different ways. Analytically, you could have solved this problem with the help of the standard mathematical procedure. You can take the antiderivative of the sine of x, you can feed the upper limit as well as lower limit, you can subtract the functions over the upper as well as lower limit, you can get the answer. But what I am saying, if you guys are learning the mathematics from me, you should learn each and everything. I would request that you should learn each and everything graphically. If you are not able to learn each and individual things graphically, probably you won't be able to understand anything. You won't be able to understand anything. Nitish Patel says the answer would be 1. Nitish Patel says the answer would be 1 perfectly well. Why? Because now we have been moving from 0 to pi, and now I don't have to stop till pi. I had to go even half loop beyond further till 3 pi by 2. My dear friends, one thing had been quite sure. The area which has been occupied by the upper lobe would have the same magnitude towards the lower lobe. That has been shown because this has been symmetrical in nature. So from 0 to pi, how much area has been occupied? That had been plus of 2. Plus of 2, that it has been already calculated from 0 to pi. 0 to pi. And once you go from pi to 3 pi by 2, the complete magnitude of the area had been 2. It would be divided by 2 because you are just going to cover its half. And may I know whether this area would be answered as positive or negative? Obviously, it has to be treated as negative. So here it goes, 2 getting divided with 2. 2 getting divided with 2. Yes, the answer has started coming. So the answer would be precisely equals to of plus of 1. Plus of 1. Agreed now? See what I am going to do over here, just with the help of graphical understanding, we are building, we are strengthening our concepts. We are strengthening our concepts. So in the same sequence, let me go forward. Let me go forward. What it has been. Let's take, it has been the third question. It has been the third question. I want the answer from each one of you. I want the answer from each one of you. And the questions are almost very semantic than the last two problems. Let's take the problem had been, you had to take the integration. Again, the function for which the integration has to be taken place had been sine of x. And let's take, you had to go from 0 to 1 not 1 pi. Can you tell me what would be the best most answer? And now if you would like to crack this problem with the help of mathematical standard procedure, definitely you are going to stuck somewhere. Definitely you are going to stuck somewhere. So I would request to each one of you, try to get the best most answer. Try to get the best most answer. Tell me what would be the best most answer for this given problem. Tell me what would be the best most answer. I want the input from each one of you. Yes, the answer have started coming. See what would happen from 0 to 2 pi. Obviously, the positive polarity as well as negative polarity would be balancing each other. It would become 0. Similarly, 2 pi to 3 pi, again there would be an extra accumulation of the area. Would it be positive or negative? Positive. So from 2 pi to 3 pi, obviously the additional area would get accumulated and the worth would be 2, which we have calculated. And again, if you start from 0 and goes till 4 pi, what would happen? All of the positive and negative lobes would be cross cancelling each other. You would lead the result as 0. So what you can do over here, one thing I've been quite sure, sir, this integration can be calculated in parts. See, whenever you calculate the area, no, the area can be calculated in parts, and if the area can be calculated in parts, why don't we take the integration in parts? We can, no, we can. So that is what we have been doing. Rather straight away jumping to the 0 to the 1 not 1 pi, why don't we jump it to the 100 pi sine of x dx. The sine of x would be completing the complete 50 cycle from 0 to 100 of pi, because it takes 2 pi to complete its one cycle. That is also sure, sir. That is also sure. So it has been quite sure the result would be 0. The result would be 0. And now what I would do from here onwards, I would take the integration to the rest of the part. I would start from 100 pi and would go till 101 pi. Again the same feature has to be used, and this remains S2. This remains S2. So till this point probably each and everything must be clear to all of us. The answer which we are supposed to get for this problem had been precisely plus of 2. In the same sequence, let me plan a next question. Let's take the problem had been the integration. Just try to understand what I exactly wanted to say over here. Mod of x minus of 1 dx, and here goes from you can take minus 2 to plus 2. This sort of problem you can experience at any moment of time. Mod of x minus of 1 over dx. Mod of x minus of 1 over dx. Tell me how will you calculate this problem? That's the first thing. Secondly, what would be the best most answer for this given problem? That should also be known to me. See what had happened over here. What had happened over here? Tell me what would be the best most answer. See, you could have seen the duality of mod of x. The mod of x have got a dual behavior. For x greater than 0, it's been defined as plus of x. For the lesser than 0, it has been defined as a minus of x. As the integration has been taken place from minus 2 to 2, that means you can break this integration in two parts, because the behavior of the function is going to be distinct, taking the reference of x is equals to 0. So you could have taken the integration from minus 2 to 0 of minus x minus 1 dx, and from 0 to 2 plus of x minus of 1 dx. That could have been the first methodology. What I am saying, that could have been the first methodology. Agreed. The second methodology would have been just focus over this structure. Graphically, and once you are done with the graphical structure of this, definitely you would be able to smash this problem within a minute amount of time. And this graph has been taken plenty amount of time. See how the mod of x would look like. The mod of x would be a V-shaped curve which would be symmetrical, taking the reference of y-axis, and the curves would be formed precisely at origin. Now because of minus 1, the complete V-shaped curve would be shifted towards downside. How the curve would look like? The curve would look something like this. Yes, would something like this. And now may I know where the exact location of the cusp has been formed? The cusp has been formed at x, obviously had been 0 because the curve has been formed at y-axis, minus of 1 because this complete curve has been shifted by 1 unit towards downside. Could you understand what I'm saying? Agreed. May I know what would be the worth over here? Anyways, focus over the curve. This curve would be still the slope would be as it was earlier. The mod of x was this, no? The slope was minus of 1 and initially it was striking over c is equals to 0. But now it has been striking over y-axis at minus 1. So the worth of c would be equals to minus 1. So may I know what would be the curve over here? The curve is simply going to be minus x minus 1 and here it's going to be plus x minus 1. And if you really wanted to know what would be the intersection point over the x-axis, what you had to do, you had to feed the value of y is equals to 0. It has been the value of y. So once you feed minus of x minus of 1 is equals to 0, what would happen? Minus 1 would go towards right hand side. The worth of x would be precisely minus 1. And here it would be plus of 1. Plus of 1. Could you understand what I am saying? Till this point, probably each and everything must be clear to all of us. And we are interested finding the area under the curve in between minus 2 to plus 2. So we had to take the limitations of the area under the curve from minus 2 to plus 2. Here goes x is equals to of minus 2 and here goes x is equals to of plus 2. X is equals to of plus 2. So one thing I had been quite sure, when you would be moving from left to right hand side, should I be moving from the left to right or right to left? Obviously I have been moving from left to right because the lower limit has been kept towards left hand side in compare with the higher limit. So the movement had been very precise and clear and we have been moving from left to right hand side. So the ijjat would be given to this area, obviously sir, but it would be counted as positive, negative, positive. Would it be counted as positive, negative, negative, negative as well as positive, positive. So let me isolate the each and individual area. Here goes this area and this area, this area. May I know what would be the area under the curve over here? Obviously it would be calculated as positive. It would be half times of base length. What would be the worth of the base length? The base length minus 1 till minus 2, definitely the base length is simply gonna be 1. Nobody should write plus and minus over here either. You can take a mod over here. Otherwise unnecessarily you will make your life hell. Yes, even function. So far the concept of the even function has not been revealed. That is why I am not going into the detailed study of this problem with the help of even function. Similarly, if we'll be discussing about its height, what had been the function? The function had been minus x minus of 1. So at any moment of point of x, you can get the value of y by feeding x as the precise value. The value of x had been minus of 2 gets subtracted. So it becomes plus of 2 gets subtracted with the 1. It would be simply 1. It would be simply 1. Similarly, the worth of this would also be this. And even the worth of this as well as worth of this would remain very same. So if you talk about this area, this area and this area, what are the areas they would be possessing? The first one would contain the area as half. You can take mod. Should I be considering positive or negative? Obviously positive. Similarly, if you would be focusing over this part alone, obviously the area would again be half. Should I be considering positive or negative? Negative, because the complete structure has been framed towards downside of the x-axis. Similarly, should I be considering this area to be positive or negative? Again negative. Again negative, and here goes the positive. End of the day, the result what we are supposed to get, it's simply 0. It's simply 0. Although it contains the area, what I am saying, although it contains the area, but the positive area as well as the negative area are going to cancel each other, Agreed, no? So probably this is the point where many of the students do mistakes, but I don't find that from today onwards you would be doing any sort of mistakes. So in the same sequence, let me do one thing. Let me frame another question. How the question must be. Let's take the question had been. Let's take the question had been, yes. It would be a very good problem. you had, just a minute, just a minute, just a minute. You had a function f of x, x into sine of x. You wants to make a design, let's take over a plane, you wants to design, or you wants to make a design over a plane where the function which you had to draw had been x times of sine of x. Find the area. I am not saying the signed area, no, I am saying find the amount of area, that means we have been discussing about the absolute values, amount of area which would be bounded, which is bounded by the given function within the range of let's take 0 to 2 pi, 0 to 2 pi, 0 to 2 pi, 0 to 2 pi, the x times of sine of x, x times of sine of x. So nobody should get confused that in ones through you can take the integration of x sine x from 0 to 2 pi. That would take place when we are discussing about the signed area under the curve. But keep in mind, my dear friends, what I am saying, just understand in this way. If you had a wall, and in wall, if you wants to make a certain shape like this, if I would ask how much the paint area is required, you won't say, sir, the paint area required is 0 because the integration from x is equals to 0 to 2 pi had been 0. No, what would be the paint area? How much the paint area has been spent over the positive lobe, the same paint area would be spent over the negative lobe, and end of the day you had to add them together. Yes, no? But the integration do not do that. The integration used to take the area in a form of sign. Wherever the area becomes positive or negative, by default they are going to get subtracted. So may I know what would be the best most answer for this given problem? Could you understand? Could you understood what exactly I wanted to ask through this question? So I wanted to know the actual area which has been occupied by the function x times of sine x from 0 to 2 pi. From 0 to 2 pi. May I know how will you approach with this problem? First, you should have a clear-cut idea how the x of sine of x would look like over the xy plane. So what I would do over here, I would take a xy plane for the reference. Just a minute. Here goes the solution part. So I would take the reference of xy plane first. I would be taking the lobe of x, which would be a straight line towards upside as well as downside, and in between the sine of x would be bounded. So the answer have started coming. The Nitish Patel states 1. Anyways, let me see that. See what is been happening over here. If you will take the integration in ones through, it has been the x is equals to 0, it has been x is equals to pi, it has been x is equals to of 2 pi. If you will take the integration in ones through, what would happen? Do you know that? Whether you are able to understand it or not, but mathematically, this area and this area is going to get subtracted. This area and this area is going to get subtracted because the integration talks about the area in terms of sine. That's the first thing. And end of the day, in ones through, if you have calculated its integration from 0 to 2 pi, nobody can deny the result would be in what? Negative. Why? Because the area which has been framed towards the upside of the x-axis had been lesser in magnitude in compare with the downside. So what would be your approach? I would like to, no, Manju, what I am saying, you wanted to calculate the actual area which has been possessed by the function x sine x from 0 to 2 pi. I am not saying you had to get its integration. Integration talks about the area under the curve. Which area? Signed area. But I am not focusing over the signed area. I am focusing over the absolute area. You can expect this sort of problem in GATE examination. So may I know what would be your approach? What would be your approach and what would be your best most answer? I would like to have this input from each one of you. I would like to have this input from each one of you. Tell me what would be the best most answer. What would be the best most answer? Tell me. If you're not able to get the best most answer, at least tell me what would be your approach. My approach would be, first I would take the integration from 0 to pi to ensure there has not been any cancellation between the areas, because mathematically internally they are going to get subtracted if you take the integration once through from 0 to pi plus onwards. So what I would do, I would take the integration from 0 to pi, and then in second part I would take the integration from pi to 2 pi, and I would take the result as modulus and I would add them together. Could you understand what I'm saying? Could you understand what I'm saying? So how the calculation would be made? You had to focus over the x times of sine of x. You can't do the calculation straight away from 0 to pi. 0 to pi you had to move. Obviously this result would be positive, but anyways, if you're not sure about it, you can do one thing, you can take its modulus. You can take its modulus, that is for sure. And from here onwards, I would be moving from pi to 2 pi. Pi to 2 pi, here goes the x sin x. Sin x dx, and again I would take the determinant or the absolute value of this integrand. And whatever the result do come, that would be my final most answer. Anyways, at very beginning, let me focus over the antiderivative of x sin x. How do we calculate the antiderivative of x sin x? It had been the integration by parts. May I know which function goes for the differentiation and which function goes for the integration? The function which are in a strict polynomial form, like x, x square, x cube, x to the power of 4, they would lead for, or they would go for the differentiation in the standard procedure. So obviously the x has to go for the differentiation, sine of x has to go for the integration. So one thing I had been quite sure, the x would be as it is, you would take the integration of sine of x. May I know what used to be the integration of sine of x? That used to be minus of cos of x. And here goes minus once again. There would be the integration of what? Integration of sine of x and the differentiation of x. The differentiation of x would lead 1, and the integration of sine of x would be minus of cos of x. The minus would come out, and it would be the integration of cos of x in respect to the dx. In respect to the dx. Could you understand what I am saying? In the same sequence, what I am going to do over here, this minus of x is getting multiplied with the cos of x, and the integration of cos of x would be precisely equals to sine of x. Sine of x. So you can just plug this function over here as well as here, and by putting their upper limits as well as lower limit, you would be getting the best most answer. You would be getting the best most answer. Could you understand what I am saying? In future, nobody should get in trap of this sort of problem, because this sort of problem have asked once in probably 10 to 15 years back, probably in mechanical. So what I would be doing over here, I would be keeping minus of x. Let's take the upper limit has been cos of pi plus of sine of pi, and now what I would do, I would feed x as 0, so obviously this goes off, and similarly if I feed x is equals to 0, this goes off, and the result would always be positive. If you will calculate, no, the result would always be positive. There is no doubt as such, because this area has been framed towards upside. So whether you take this determinant or not, the result has to be positive, because this has been our core understanding. Now the same concept has to go on over here. What it would be over here? See. What would be over here? Here it would become minus of 2 pi. Cos of 2 pi. Cos of 2 pi can be simply written as cos of 0. Cos of 0 can be simply written as 1. And here it goes sine of 2 pi. And we know the sine of 2 pi, which is very same as sine of 0, and the sine of 0 is simply equals to of 0. That is also okay. Now what I would do next, I would take minus sign over here. And here I would be feeding minus of pi. Could you understand what I am saying? And instead the x, again the pi has to be fed in. Cos of pi used to be minus of 1. Minus and minus becomes plus now. And now when I would feed the sine as pi, by default we know the sine of pi would again become 0. No, why I am taking mod? Because here I am not interested to find the integration. Here I am interested to find the actual footprint of the area which has been encapsulated by this function. See, just tell me one thing. If you are drawing a rangoli in the poly season, you can't say no that this area and this area would be cancelled each other. So the amount of area of rangoli which would be required would be 0. No. Once you will be talking about its absolute value, this and this would get added. This and this would get added. That is why the modula have been taken. Modula have been taken. Tell me what would be the best most answer. So the answer have started coming. Answer have started coming. Tell me what would be the best most answer which we would be getting from this particular calculation. Which we would be getting from this particular calculation. So from here easily you can calculate all of them. This had been 0. This had been cos of pi, which should be minus of 1. Minus of 1 gets multiplied with the minus of pi. The result would be plus of pi. Anyways, whether you take its modulo or not does not make any sense. And here, any mistake had been taken place probably. Because this area by default would be larger than this area. May I know where the mistake had been taken place? Somewhere here the mistake had been taken place. Because this area, okay, it has been there, no? Minus of 2 pi and minus of pi. Yes. And that had been minus of 3 pi. And once we'll take its mod, the result is gonna be 4 pi. And if you could have taken the integration in once through, the answer would have been pi could have been subtracted with 3 pi. The result would have been minus of 2 pi. That's the difference what you would be expecting while you would be doing the integration in once through, and when you would be taking the actual area occupied here as well as here as well as here as well as here. So this sort of problems are expected in future. You can experience this sort of problem at any moment of time. So may I know till this point each and everything is clear or not? If it is clear, just write clear over the live chat, so at least I'll have the fair idea that you guys are getting each and individual concepts. So in the same sequence, what we are going to do over here, let me bifurcate this digital board once again. And let me frame another problem. Which kind of the problem you can have? Yes, the integration from 0 to, let's take which kind of question should I be taking? Let's take 0 to pi. No. Let me change this problem a bit. What I am saying, again, you had to find the absolute area occupied by sine of 2x from x is equals to of 0 to pi. I want this answer from each one of you. What I am saying, the same calculation has to be made which has been made earlier. You had a function sine of 2x, and you wanted to calculate its absolute worth, which has been encapsulated in between 0 to pi. Tell me, how do we calculate this, and what would be the best most answer for this given problem? I know many of the students are going to get the huge amount of problem while the calculation of this. The same process has to be followed, because we have been discussing about the absolute area, the complete contour areas which has been framed towards upside and downside has to be added together. And once you will calculate to the integration in once through, probably you could encounter such a situation where the positive lobe as well as the negative lobes area is getting cancelled. Tell me, can I take this integration once through or not? Yes or no? The answer has to come in a form of yes or no. Can I take the integration in once through? The answer should come in a form of live chat, yes or no. Can I take this integration once through, where the absolute area has to be calculated from 0 to pi? Yes or no? It requires deep thinking. I am not saying it's a very difficult problem, but certainly requires the deep thinking. Tell me, I would like to have the input from each one of you. Can you calculate this thing in once through? Yes or no? No. The Manju says no. Anyone else apart from Manju? No, I can't. Why? Because the sine of 2x, the x has got multiplied with 2. That means it has been a compression of sine of x. it has been a compression of sine of x. That means the curve had a complete period as 2 pi, now would be shrink to pi itself. Now it would be shrink to pi itself. Yes, no? So what I am saying over here, how the sine of 2x would look like, obviously it would be a sinusoidal signal. It would be a sinusoidal signal. It is x-axis, it is y-axis. May I know where the worth of sine becomes 0? At 0 radian. So if you feed 2x as 0, definitely the x would become 0. So here it becomes 0 radian. Next time at pi. At pi, the 2x has to become pi. The value of x would become pi by 2 itself. And similarly, instead the 2 pi, here it would be pi itself. Here it would be pi itself. Could you understand what I am saying? I know many of these students are going to do the mistakes on this sort of problems because they are not very well acquainted with the graphical understanding. So what we are supposed to do over here, either you can take the area under this curve, and you can just multiply with 2, because this area should also be considered as a positive value, because we have been discussing about its absolute value. The same thing has to be applied. Sine of 2x, the integration has to be taken place from 0 to pi by 2. Whatever the value you get, you had to just multiply with 2. Tell me what would be the bestmost answer. I would like to have the input from each one of you. Take your time, and within maximum 40 to 50 seconds, you must be able to answer it well. You can do one thing, you can keep 2x is equals to of 2t, and once you keep 2x is equals to of t, definitely there would be the changes in their lower limit as well as upper limit. From there, you can easily get the area of the first lobe, and by default, you would just be multiplying with 2. Tell me what would be the bestmost answer for this given problem. Srinoy, Chakravarti, Manju, Pranali Ingule, all of them are saying the bestmost answer would be 2, which is precisely correct. Agreed? May I know how to deal with this sort of problem? This problem would be dealt with the same concept, and what had been that concept? Go with the functions curve, and wherever the change has been taken place. What does it mean by the change? Where the f of x goes from positive to negative or negative to positive, there you have to take the change, and correspondingly you have to take mod in each and individual domain. If in one through, if you will take the integration from 0 to pi, the worth would become 0, and you are saying that you are creating a rangoli in Diwali, and you do not require any of the rangoli at all, or rangoli powder at all, because sir, area requirement is 0. That had been assigned area, and if you talk about the practical areas which we encounter in daily basis, there each and everything is being additive, and there we can do that calculation using the integration once again. Agreed, no? So this is the point where many of the students used to stuck on. Now let me focus over the notation of definite integral itself. May I know how it had been? fx dx, where you used to have the limit in terms of a and b. Yes, that is fine, sir. No issue. See what they wanted to communicate through this mathematical expression. Obviously, we wanted to calculate the area under the curve. What I am saying? We wanted to calculate the area under the curve. From x is equals to a, which has been a vertical line, from x is equals to b, f of x taking the reference of x-axis. So let me take a reference of f of x. I have drawn a random f of x. And let me take the reference of x is equals to a. Somewhere here you would be having x is equals to a as per the data, and somewhere here you had the x is equals to b. Here we had x is equals to a, here we had x is equals to b. And obviously the area under the curve has to be encapsulated taking the references of x is equals to a, x is equals to b, x-axis as well as f of x. Leave out each and everything. What does it mean by f of x dx? What does it mean by the f of x dx? It has been a area area of triangle or area of rectangle, where its width in the direction of x is being indefinitely small, you would understand from here now, you would be able to understand from here now. See what I'm saying. Dx, what does it mean of it? The dx is infinitely small displacement in the direction of x. This has been the direction of x. Whatever the displacement takes place in the direction of x would be treated as the displacement in x, but it has been infinitely small in length. What does that mean of it? You have taken a very small displacement over the x. Although it is visible, but theoretically speaking, it's infinitely small in length. It is very nearly spaced. So what we have been doing over here, if we draw a rectangle over here, may I know what would be the area of that rectangle? The area of the rectangle is being defined as its width. Obviously the width had been d of x, and its height. May I know what would be the height of it? Many of the students would think, sir, its height is little bit curvy. You can't take this height as a very flat curve. You can. Why? Because if the length or the variation towards the x has been infinitely small, what would happen? It would be a very thin rectangle, and if it is very thin rectangle, you can take its top would be almost flat, parallel to the x-axis. So may I know what would be its height? The height would be very same as the worth of the function at that moment of point itself. Why don't we write f of x itself? Could you understand what I'm saying? Why don't we write this as f of x itself? And one of the worst thing regarding this, f of x can be positive as well as negative. If it is being framed towards upside, it would be treated as positive, and if it is being framed towards downside, it would be treated as negative. So what we are doing, I have been sliding this rectangle from x is equals to a till x is equals to b. Till x is equals to a to certain point, let's take C, all of the rectangle which has been framed, that had been framed towards downside, and the value of f of x has been negative. So whatever the area has been occupied from x is equals to a to C, it has been encountered or calculated as negative value. And that has been done by the integration now. And as it moves from C to B, again the positive calculation has been made. So what does it mean by the integration or definite integration? Definite integration calculates the area under the curve. What I say? Sir, height is continuous changing. That's fine. No. What's the problem over here? Height itself is f of x. No. If you'll go at any moment of x, definitely the f of x has the countability of height. That is why it is being written as a function of x, which would change everywhere. Agreed? End of the day, taking the sum of each and individual area which has been occupied by the different rectangle, you would be sum up your actual area. But that area would be a signed area, because this would be treated as negative and this would be treated as positive. End of the day, area is in your hand. And such a beautiful thing regarding the integration, if somebody would ask, my dear friend, can you get the area under the curve from 0 to pi? How will you calculate? Would you calculate it manually? If you do not have sadhana of integration, how you had to calculate this integration or the area? Area has to be calculated manually. But integration is such a huge relief, such a complex function like e to the power of x, maybe e to the power of x square, e to the power of minus x square, sin x into cos x, such a huge as well as complex function. And if you wanted to have its integration in a certain limit, can be easily calculated. So till this point, each and everything is clear. If it is clear, write clear. This is all about the today's video. We would start continuing from the same section of study. Anyways, as I have been saying again and again, I would try to put this PDF on my Telegram group. So in parallel, you would also be getting a proper notes. But I would request to each one of you, try to maintain or try to retain your own notes. Sir, how we understand where to find the absolute area. My dear friends, whenever they have been talking about the integration now, forget about each and everything. The positive and negative area is going to get subtracted. That's for sure. That's first thing. Now, sometime they may also ask how much actual area would be required. How much actual area would be required to frame a certain figure. There, obviously, the positive would be treated as positive and negative would also be treated as positive. Sir, if limit are not there, can we able to find the integration? Obviously, yes, my dear friends, Anil. That is called antiderivative, and that is why the component of C do come. So what I would do, Anil Kumar, probably this is not the right time to encapsulate or incorporate your doubt which you have posted over the live chat. Probably in next class, definitely I would try to take your doubt there itself. So this is all now. Okay, then we'll meet tomorrow precisely at 9 p.m. So keep in mind, my session timing would remain very same. The student who are from electrical, electronics and instrumentation, they can attend my session at our new channel Gate Academy 2.0. There my mode of communication used to be in Hindi. So the student who are from the southern part of our belt of our country, who are not well acquainted with the Hindi, probably they may face a bit problem, but still they would find that video very fruitful. The timing used to be in between 6:30 to 7:30, and daily basis we would be having the mathematics class or our Gate Academy Global, and the timing would remain very same in between 9 to 10. Okay then, bye bye, take care, good night.